the log graph is like an inverse function compared to exponential graph. The simplest logarithm graph has this equation, log base EX. Okay, so log EX, log AX. So the graph looks like this. Okay, the graph looks like this. And it has asymptotes at x equals to 0. There's an asymptote at x equals to 0. Okay, we have domain R plus. We have domain R plus. Okay, R plus means round bracket 0 to infinity, not including 0. Okay, not including 0. If you talk about square bracket 0 to infinity, that is equivalent to R plus union the value 0. Okay, needs to distinguish between the two notations. And round bracket 0 to infinity is just basically R plus. Okay, and the range is R this time. Have a think about the exponential graph, e to the power of x. The domain is always R. The range got some restrictions. It's like above something or below something. But like for this one, the range has no restrictions. The range is basically R all the time. And the domain is from one point to the right or from one point to the left. I will talk about how to find the domain. Okay, I will talk about how to find the domain. We can find the domain by solving equations, or we can find domain by look at the graph. Okay, if we trying to find domain directly without sketching the graph, what we can do is we look at the value put into log. Okay, the thing I have circled. So again, the general solution is capital A times log base A bracket K bracket X minus B plus C. For when we sketch the exponential graph, like exponential, we have y equals to A times lowercase a K X minus B bracket plus C. So it's pretty much the same. Okay, it's pretty much the same. We use same letters to represent different dilations. So if we want to solve for domain, okay, let's highlight this part. Domain, oh, not this one. Domain, this one. Okay, this line here. So what is the domain? The domain is the thing you put into the log needs to be greater than 0. Because domain for log is greater than 0 all the time. You can't have log e negative 2. Okay, you can like forever have like positive values. Okay, not including 0. So what you need to basically solve is the thing you put into log, make that equals greater than 0. For example, this equation. If I just want to solve for domain, I just need to have 2x minus 4 greater than 0, and you have x greater than 2. And that is my domain. So my domain is x belongs to 2 to infinity. Okay, 2 to infinity. That's one way to solve for domain. Okay, that's one way to solve for domain. And we can look at graph. So if we want to look at the graph, we need to know how to sketch graph first. Okay, we need to know how to sketch graph first. Okay, like how do we sketch graph is very similar to exponential, but it's a little bit harder compared to sketch the exponential. So number one is asymptotes again. In exponential, there's a horizontal asymptotes, and now we have a vertical asymptotes. So first one is find the asymptotes. So what is the asymptote? The asymptotes is like solve kx minus b equals to 0, x equals to b. So x equals to b will be the asymptotes. Okay, x equals to b will be the asymptotes. Basically, we solve for that equals to 0. Why I make that equals to 0? Because 0 is the value. Okay, separate the, like it's possible to take or it's impossible to take. 0 is the line. Separate that. So equals to 0 will be that asymptotes. Okay, it will be that asymptotes. So we solve for the whole thing equals to 0. That x you have solved will be the vertical asymptotes. That's number one. Number 2, again, base shape. It's exactly the same compared to what we think for exponential. So base shape. Okay, we have 2 base shape again. If that a is greater than 1, and if that a is in between 0 and 1, that a value can be greater than 0 but not including 1. Okay, the domain for a is R plus except 1. That is the domain for a. So now you have 0 to a, 0 to 1, and 1 above. 1 and 1 above. So if that base is greater than 1, we have increasing graph, same as the exponential increasing graph. So increasing graph looks like this. Okay, in the right hand side of the asymptotes, and it's an increasing graph. If it's in between 0 and 1, that will give me a decreasing graph. It's again still to the right hand side of the asymptotes, but it will be decreased. So the only difference between exponential and logarithm will be exponential is horizontal asymptotes, and this one is vertical asymptotes. Okay, exponential is above the line. This one is to the right hand side of the line. It's quite makes sense. So we have increasing graph or decreasing graph. Okay, this decreasing one is approaching to the asymptotes in that side and then decreased further away from that. And number 3, we'll think about capital A value. Okay, capital A value, the A you times in the front, or you can think about K, doesn't matter. So if A less than 0, reflected in x-axis. Okay, it's changing the y value, so it's reflecting x-axis. It's reflect down. Okay, if you have 1, 3, now you have 1, negative 3. You reflect by the x-axis. So the two base graph will be reflect in this way. Okay, this one will look like, I shouldn't use this color. Okay. This one will reflect in the x-axis, will become this one. And this one reflect in the x-axis, you will have this shape. Okay, that's the 2 different base graph. Okay, it's according to the 2 different base graph. So that one become this, and that one become that. And number 4, the K value. If K smaller than 0, then reflected in y-axis. Okay, in y-axis is that way. So the first base graph, okay, the first one, A greater than 1. The first base graph will be reflected in the y-axis. We'll have that one. If it's in between 0 and 1, it will be reflected by the y-axis. You have this shape. It will have this shape. It's only reflected by y-axis. Okay, it's only reflected by y-axis. And you can also reflect twice. Okay, you can also reflect twice if both of them are negative. Okay, that's number 4. After we finish number 4, we have to make sure what the shape actually looks like. Okay, what's the shape actually looks like. So number 5. Okay, do you think there always got a x-intercept or y-intercept? Will there always be an x-intercept or y-intercept? Now, x or y? Like there is something always exists. Always exists x or always exists y? X. Okay, x-intercept. Because the range is R, I can always have y equals to 0. The range is R, I can always have y equals to 0. So find x-intercept. Because I will always have x-intercept. Number 6, find Y intercept if possible. Find Y intercept if possible. Otherwise, find any point. Find any other point. Because you need 2 points on the graph. So if you can find x-intercept, you can find y-intercept, that would be good. Otherwise, you'll find any other point.
Do you always need 2 points on both kinds of graph, or just in general?
General, you need to have 2 points on the graph. Like especially linear, quadratic, like you need to use 2 graphs to show dilations. Well, if it just pass 1 point, there are a lot of, say, quadratic can pass 1 point.
Oh.
So you just need another point to make sure what is the dilation. It's better to label 2 on the graph. Okay, so what do we have below here is just the shape, the 8 different shapes you can have for different graphs, like different A values and different negative values. That's what you have. But like that, okay, I would suggest if you can take notes to the exam, you can take it in and then check your answers by using that graph. Well, you're not really using those 8 graphs, you're not memorizing those 8 graphs to sketch. Okay, you use this method to think about all the reflections to sketch. And this one will be more help you to check your final answers. Okay, to check your final answers. Okay, let's have a look at example. It's easy to talk about examples here. Okay, the first one. We want to solve for asymptotes first. Well, why I said it's a little bit harder compared to exponential graph? Because exponential graphs, asymptotes will be directly given is the C value at the back. And for this one, you will like have think about like for 1 second to solve for the bracket equals to 0. So okay, x and y. So number 1, I will solve for asymptotes. So asymptotes is x minus 1 equals to 0. The bracket equals to 0. Therefore, x equals to 1 will be the asymptotes. Okay, what we have is x equals to 1 here. Number 2, base shape. The base shape is lowercase a equals to 2. That is greater than 1. Then the base shape is this shape. That is the base shape. Number 3, a equals to capital 1. No reflection. Number 4, lowercase k equals to 1. No reflection. So the shape of the graph is just like that. Okay. You think about whether there's reflection or not. So there's no reflection. The graph will be directly looks like that. So number 5, they always have y-intercept. So when y equals to 0, log 2x minus 1 equals to 0. X minus 1 equals to 2 to the power 0. X equals to 2. So 2, 0 will be the y-intercept. So you find 2, 0 here. Okay, the graph will again looks approximately like that. Will there be x in y-intercept? No, no y-intercept because it's this side. Okay, asymptote stop it. So I need to find any other point. What x value you may choose? 3. Okay, yep. So when x equals to 3, because 3 minus 1 gives you 2. So y equals to log 2, 3 minus 1, which is 2. So log 2, 2 will give you 1. So you will have coordinates 3, 1. 3 is here. 1 is here. Okay, that's the shape of the graph. So you have to choose 3, 1, and 2, 0. Okay, this log graph looks pretty good. Okay, that's how we sketch it. But this is an easier graph. This is an easier graph. Let's sketch another one. Let's sketch another one. Okay, what's the domain for this graph? Can you see the domain now? What is the domain? By looking at this graph. Domain, what is the domain? 1 to infinity, not including 1. Okay, good. And the range is always R. Unless there's some special thing happen to stop your domain for somewhere, otherwise the range is always R. Okay, range is always R. Okay, next one. Next one I know of a domain will be 2 to infinity. So let's have a look. First, I will solve for asymptotes. So asymptotes will be 2x minus 4 equals to 0. Therefore, x equals to 2. X equals to 2. Is x equals to 2. Okay, next thing is the shape of the graph. Okay, next thing is the shape of the graph. So base shape. A equals to 3 is greater than 1. Therefore, is an increasing graph like this. Okay, it's an increasing graph like that. To the right-hand side of the asymptotes is increasing. Number 3, think about the reflection. Capital A equals to -3 because it's the number times in front of the log. Okay, times in front of the log. And that number is less than 0. So it will get reflected. It will get reflected. Okay, reflected by which axis? X or Y? X. Okay, reflect down. Okay, down. So it's X. So if it's reflect by X, okay, think about reflect by X, then it becomes this shape. It's not changing side. It's still right hand side of the asymptotes, but going that way. Okay, number 4, K value. K equals to 2. K is the coefficient of X. Okay, K is the coefficient of X. And there's no reflection, so the graph stay at the previous stage. Okay, stay at the previous stage. Number 5, solve for x-intercept. Solve for x-intercept. Did I write x-intercept on the top? Yes. Okay, solve for x-intercept. That's when y equals to 0. Well, your graph looks like this. Okay, somehow that. Okay, when y equals to 0. The log 3 2x minus 4 will be 0 because 0 times minus 3 will be 0. So 2x minus 4 equals to 3 to the power of 0, which is 1. So 2x equals to 5. X equals to 2.5. Okay, 5 over 2. And 2.5 is here. That's your x-intercept. Okay, what x value you choose? There are obviously no y-intercept. The graph is to the right-hand side of the asymptotes. What point you will select to put inside again? Well, basically you can choose any. You can choose 3. You can choose 5. They're all good. Have a think what I want to make the inside to be. I want to make the inside to be 3. Then log 3 will be 1, right? Log 3 will be 1. Then what x can make inside to be 3? Yeah, what x can make inside to be 3? 3.5. Okay, 3.5. So x equals to 3.5. Y equals to minus 3 log 3.5 times 2 is 7. 7 minus 4 is 3. So that's log 3, which is 1. So y equals to negative 3. So 3.5 and negative 3. 3.5 is here. Negative 3 is here. Okay, that's the shape of the graph. That's 5/2, 3.5 is 7/2, negative 3. Okay, that's this graph. So you can see the domain. The graph is to the right-hand side of the asymptotes. So the asymptotes is 2. So domain will be 2 to infinity. That's exactly the same as what we solved before. And range is R as well. Any questions about this? Yeah, those two are pretty easy. Let's see a complex one here. Okay, for this graph. Okay, first one is the asymptotes. Asymptotes is minus x plus 2 equals to 0, 2 equals to x. So x equals to 2 will be the asymptotes. X equals to 2. Okay, number 2 is the base graph. Okay, base shape is A equals to a half. That is less than 1. Then the graph will be decreasing graph. Okay, this lowercase a value is not compared to 0, it's compared to 1. Because it will always be greater than 0. So let's compare the relationship between that and 1. It's less than 1, so it's a decreasing graph. Number 3, A equals to 1. There's no reflection in the x-axis. Okay, that's greater than 0. Oh, good. Number 4, K value equals to negative 1. Is the coefficient of x. Okay. Reflect in which axis? Y. Y, okay. Y-axis. Then the graph will be this shape. Okay, this shape. Okay, so you have a graph like this shape already. Or you don't need to sketch it, you just know like what it looks like. And you can see there's x-intercept and y-intercept. Okay, both x-intercept and y-intercept. That's why I want to sketch it at the beginning to think about what we can solve. So number 5, Okay, when y equals to 0, log a half minus x plus 2 equals to 0. Minus x plus 2 equals to a half to the power of 0, which is 1. Minus x equals to minus 1. 1 minus 2 is minus 1. X equals to 1. X equals to 1. So the point is 1, 0. Okay, we have another point. Can solve number 6 when x equals to 0. Y equals to log a half 0 plus 2, which is 2. What that equals to? Yep, -1. Because that equals to 2 can be said as a half to the power of -1. Okay, 2 is a half to the power of -1. And then we can bring the -1 to the front. Therefore, y is just -1. Okay, so we have 0, -1 for the y intercept. Is here. And the shape of the graph, okay, shape is like that, this red one. So that's the shape of graph. Asymptotes is here. We have 0, -1, and 1, 0. And 1, 0. Okay, any questions so far? Okay, if no, we can look at the last one. Yeah. Y domain is supposed to be positive. Okay, the domain is not like, it's not x is positive, it's the bracket whole thing is positive. The whole, what you insert into log is -x plus 2. That needs to be positive. So it's minus x plus 2 needs to be greater than 0. That's how we solve for domain. And then you plus the x to that side, is x less than 2. X less than 2. The domain is not the x is positive. It's the thing you can put into log needs to be positive. Okay? So for example, if you take y equals to 2 or 3, let's say x equals to 3, there's -3 plus 2. You have -1 in log, which is impossible to solve. So you can't have positive values in this case. Like if you have 3 here, then it's -1. You can't have -1 in the bracket, so can't solve. So the domain in this question will be like -∞ to 2. And the range will still be R. Okay, you can see from the graph, what graph has, that will be your domain. Okay, that side. Okay, number 4. -3/2, that, okay, this is quite complex. My graph should look like that. Okay, so first, asymptotes. Asymptotes is minus that -2x minus 3 equals to 0, -2x equals to 3. x equals to minus 3 over 2. Okay, minus 1.5. That is the asymptotes. X equals to minus 3 over 2. Okay, next one is base shape. The base is 0.3. The base A equals to 0.3, which is less than 0. Okay, less than 0. Less than 0, you will have a graph like that. That's the shape of the graph. Decreasing graph. Number 3, A is minus 1.5, which is less than 0. Will get reflected. Reflected by which axis? X. If it's get reflected by X, that will look like this. Okay, reflect down. You have this graph. Or you can talk about K first, it doesn't matter. Now K equals to minus 2, which is the coefficient in front of X. Less than 0 again. Will reflect by which axis? Y. Looks like this now. Okay, reflect down and then reflect to the left. So what graph you have? You have a graph like this. Okay. This shape. Number 5. When y equals to 0. Log 0.3 minus 2x minus 3 equals to 0. And minus 2x minus 3 equals to 0.3 to the power 0, which is 1. Plus 3, which is 4. Divide by minus 2, you have minus 2. So minus 2, 0 will be the x-intercept. This point is here. Okay, number 6, I need to choose another point. Again, same thing. I want to make the inside to become the same base, which is 0.3. So I want to make that become 0.3. So I can have minus 2x minus 3 equals to 0.3, minus 2x equals to 3.3, x is equals to minus 1.65. Okay, minus 1.65. So when x equals to minus 1.65, y will be minus 3 over 2 log 0.3 bracket 0.3. On purpose, I want to make the bracket to become 3. And I find that x is minus 1.65. And I have y equals to minus 3 over 2. Okay, so minus 1.65 and minus 1.5. That's minus 1.5, minus 6.5 is just over that, and minus 1.5 is here. It's this point here. Okay, so what I will have is this shape. In this shape. So the point I have is minus 2, 0, and this one is minus 1.65, minus 1.5. Okay, the domain for this graph now is negative infinity until negative 3 over 2. It's all negative values. Okay, negative infinity until here. And the range basically it's R. Okay, I have just shown you 4 examples how to sketch log graphs. It's quite similar to how we can sketch exponential graphs. So you definitely need to know how to sketch graph. Okay, it's very important skill. It's very important skill. Okay, and as I said, the logarithm graph and exponential graph, they are inverse functions. Okay, they are inverse. The inverse of log is an exponential. The inverse of exponential is a log function. So let's have a think. The following 2 questions. I will just do one with you. Okay, I'll just do one with you. I will do this one with you. You can do the first one. It's exactly the same. I want to find the inverse of each of the following and sketch both functions. So I want to find the inverse of this function. First, let's sketch this function on the graph. Okay, let's sketch this function on the graph. So we have log 3 minus x plus 3. Okay, try to draw it to scale. Okay, so first thing is asymptotes 3 minus x equals to 0, x equals to 3. X equals to 3 will be the asymptotes. Okay, number 2. Base equals to 3 greater than 1. That is just an increasing graph. Number 3, capital A is equals to 1 greater than 0. Nothing wrong. Number 4, K equals to negative 1. The coefficient of X is negative 1. Less than 0. Reflect in which axis? Y axis. So it will be this shape. Okay. Number 5, when y equals to 0, log e bracket log 3 bracket 3 minus x equals to negative 2. 3 minus x equals to e to the power of negative 2. X equals to 3 minus 1 over 9. It's 29 over 9. Which is a point really close to here. When x equals to 0, y equals to log 3, 3, which is 1. 1 plus 2, y equals to 3. So 0, 3 is the y-intercept, which is here. That's the shape of the graph. That is the shape of the graph. Now I will label this is 0, 3, and that is 26 over 9, comma 0. Okay, if we think about inverse, okay, just don't think about the equation of this inverse. Just let me know if the graph got a x a vertical asymptote at x equals to 3, what the asymptote, the inverse function will have? Y equals to 3, okay? So if you have vertical x equals to 3, reflect by the line y equals to x, you will have y equals to 3 as the asymptotes. So you will have asymptotes exactly here. Okay, you have point exactly here. Okay, tell me if you have 0, 3 on the original graph, what point you will have on the inverse? 3, 0. So here is 1 point. And if you have a point 26/9, comma 0 on the original, what you will have on the inverse? 0, 26/9. Okay, so it's a point a little bit below 3, which is this point here. And also you will have and like reflect by the line y equals to x. Okay, it's reflect by this line. So the point that intersects, not here, the point that intersects here, the graph will also pass that point as well. Okay, it's y equals to x. That point is y equals to x. If original graph have that point, then the inverse will have that point as well. Therefore, the graph will be, again, there is 1 point, there is 1 point, there is 1 point. And then reflected, that's the asymptotes. Okay, that's the shape of the graph, inverse. Okay, the pink one is the inverse, f inverse x. And the green one is fx. And I need to label the point. Here is 0, 26/9. I don't know what is that point, but I can calculate. This point is 3, 0. And this pink line will be y equals to 3. So the pink graph is the inverse graph. The pink graph is the inverse graph. And you can see that's an exponential. Okay, that's an exponential. You can see the pink one, asymptotes at y equals to 3, and it's downward exponential graph. How do we find inverse graph? How do we find the equation of the inverse? Okay, so let's have a think. What's the domain for original f? That's the step we're trying to solve for inverse. Number 1, domain for the original graph is this green one, is -infinity to 3. Number 2, the range of the original graph is R. Okay, range for the logarithm is just R. Number 3, just change the position for x and y. So x equals to log 3 minus y plus 2. Number 4 is rearrange. So 3 minus y equals to 3x to the power of x minus 2. So minus y equals to 3x minus 2 minus 3. Positive y equals to minus 3x minus 2 plus 3. And you can have a look at this shape. This shape, it is true because you have horizontal asymptotes at 3. So we have horizontal asymptotes at 3. So that's this graph. And we need to write number 5, domain for inverse equals to the range of that, which is R. Number 6, the range of the inverse will be the domain of the original is negative infinity to 3. So we can write F inverse R mapping to R, comma, F inverse X equals to minus 3x minus 2 plus 3. That's the rule for the inverse. That's the rule for the inverse. Similarly, you can try the front one by yourself, okay, by using exactly the same method. Draw the exponential graph, find the asymptotes, make it that to the vertical one, find the x-intercept, make that into the y-intercept, find the y-intercept, make that into the x-intercept, and connect the graph. And connect the graph. Okay, we finished the whole chapter and we won't have class on Thursday. Friday we'll have some fun, so don't take any like mad stuff come in. Okay?